Hello, IEP Psych. We're starting with notebook page 3, research methods and experiments. This may take 2 or 3 videos. Remember, the videos cannot exceed 15 minutes. And research methods and experiments are crucial for the FRQ. There's always at least one that mentions it. There's an experiment going on. So I do not want to rush through this. If it, it'll take as many different movies as we need or videos as we need to make. Also, as a reminder, I apologize in advance if you hear strange noises or Jack. He is playing, and every toy he owns sings and talks, whatever. All right, so here we go. Okay, class, experiments. Experiments are required to confirm consistent, repeatable results. Remember, psychology is a science. So we want to make sure that whatever experiment we're conducting is consistent. If you do an experiment and then someone else tries to conduct it with completely different results, then this was an anomaly. For an experiment to have validity to it, to be something that we want to study, we need to make sure that it's consistent and that every time you do this experiment with different groups of people or different factors, you're going to get the same results. So to confirm the validity of a psychological finding, experiments are pretty much required, particularly when it comes to cataloging and tracking behavior. So we're initially guided by an intuition, this internal feeling or compulsion that you have, and scientific objectivity and research are required to root out biases. Biases, again, those are things that you may preconceived ideas before you enter this experiment. So you have an intuition, you have biases. The experiment needs to not include that. That's not exactly what I'm saying. You're first guided by an intuition and bias, but the experiment hopefully alleviates that. So you need to first have a theory, right? Explanations that organize observations and predict an outcome. So you theorize A. Then you come up with the hypothesis, which is the testable prediction related to the theory. And then you come up with your operational definitions, the exact procedures so that the experiment can be replicated. As an English teacher, when I think of theories, I think of like the topics, the ideas, and the hypothesis is like the thesis statement, right? So my son is just destroying this room. I'm sorry. So we have a theory, if anyone watched 100 Humans, that if your last name was part of the end of the alphabet, that you kind of got like gypped out of something in life. So the hypothesis was that folks that had last names that ended with a later alphabet letter had lower like self-esteem. And then the operational definitions are kind of like the rules, and they are the exact procedures. And this is important when you're conducting your experiment, because if you conduct it and I want to do something similar to make sure that this experiment is consistent and has repeatable results, your operational definitions must be very clear. You need to lay out this list of rules for me so that I can follow them and get this repeatable, similar, identical results. So psychological studies consist of observing human behavior for the most part, right? We want to figure out why folks are the way they are. We're going to look at how they behave. Factors are adjusted and controlled, and scientists wait to see the change in a thought or a behavior from the subjects. So you have your theory, you have your hypothesis. Now you got to figure out, well, what type of experiment am I going to conduct in order to prove this or figure this out? So one might be a correlation studies. So we're looking how two factors are linked and can predict one another. Correlation does not prove causation. So just because a school has less funding, it doesn't mean that it causes lower performance, although the two often do come together. So correlation studies is where we're looking at links, but one of the issues with that is that just because there's a correlation doesn't mean that that's the necessarily a causation of what's going to happen. Cross-sectional study, a type of observational study that analyzes data from a population or a representative subset, a specific point in time. So if years from now we're going to look at how the coronavirus impacted people, we may choose let's say we do it 10 years from now when you guys are in your mid-20s. We want to see how high school students were impacted by this. We're going to choose a subset of people in a specific age. You could also pick maybe just one gender. Maybe you could look at a socioeconomic group. So it's depending on the type of experiment. You may want to have a specific group of folks as part of your experiment. You're going to do that cross-sectional study where you're observing and analyzing of one particular population. Then there's longitudinal study and observational research, which gathers information on the same subjects over a long period of time. So if we wanted to see how, let me think of a good example. Maybe it could be something like, how does CTE classes impact a student's self-worth? Okay, they would take you guys, or a group of ninth graders, and stick with those ninth graders through high school and then into college, and then see how their self-worth was. I guess at the same time, you'd also want to do that with students that were in a gen ed population. But the idea is that you have one group of folks and you study them over a period of time. If anyone was interested, it's not as fun as 100 Humans, but there's a documentary series called Babies, which it's not exactly longitudinal for now, but because they're looking at babies when they're infants. But if the next season came out as toddlers and then they came out, they could continue studying these people over periods of time. That would be longitudinal studies. Then we have a survey, a questionnaire that self-reports anonymous behaviors and characteristics of a certain group. You have taken tons of these. The school has given you surveys. My class, I think, just gave a survey, right? If you think that this method of teaching was a good idea. So again, it's a bunch of questions. You self-report. They're anonymous. It's the behavior and characteristic of a certain group, right? So we give out surveys to students, or surveys to teachers, or surveys to, actually everyone's taking a survey right now. There is the census is being conducted right now. It's mandatory that you conduct that. If you have questions, I think there's more information on the Queens Tech website. But that is a type of survey, and that survey is extremely important. It lets us know how many folks live in a certain area, so we can provide hospitals and education and things of that nature. So, and then naturalistic observation. I love the definition, unhindered observation of animals or people in their natural environment. I feel like someone in a class said that this reminded them of Peeping Toms. Kind of, I guess. It's where you're just looking at folks or looking at animals just behave. So if you ever watch like a nature documentary, they're on Disney Plus. They're super interesting. There's ones about bears, and I was watching about monkeys. So that's a naturalistic observation. You're just like checking out what they're doing. And based on their interactions with each other, their actions, you can come up with some observations and maybe some hypotheses and theories. And then finally, there's a case study, which I'm familiar with as a teacher, where you're taking an individual or a group and diving deeply into them. And by diving deeply into them, that person or group, you come up with a universal truth for everybody. So if we were to track just this AP class and ask questions and do an in-depth study on you, what we learn about you, we're going to apply to other and assume about other AP classes. All right, so you picked what kind of experiment you're going to conduct. Now you need to group folks. So there are different types of groups. These, I think, are super, super important to know in general. They're super important to know for an FRQ, okay? So here is the premise. We are conducting an experiment where we're trying to see if zinc reduces common cold time. So you need to conduct the experiment that tests the effectiveness of zinc on reducing the common cold. So first off, you need to have two groups. The experimental group, the group that is exposed to the treatment. That group is going to be, they're going to have a cold and you're going to give them the zinc. Then there's the control group. The group is not exposed to the treatment. They get placebo or water pills, and the folks in each group do not know that they're in that group. So it's not like you have a cold and like, all right, you're in the control group. Good luck not getting anything. You don't know if you're part of the experiment which group you're in. So in order to eliminate bias, the experiment administrator and the subject I'm sorry, to bias or interference by the experimenter, the experiment administrator, or the subjects, it's best to make the two groups unknown. Now, I love this phrase. I don't know why. I've used it on multiple choice tests. If both the patient and the staff are unaware of who's getting which medication, that's a double blind. And I think that's important to do if you can, so that the doctor doesn't have their own, or the researcher doesn't have their own biases upon talking to someone or how you interact with them, if you knew if they're part of the experimental or the control group. So again, we have to have one group receive the treatment, one group doesn't, and if there's a double blind, nobody knows which people are part of which group. Okay, so now you've conducted the experiment. So now you got all this data. So all these numbers, what do I do with them to make them make sense? So there are primarily two types of graphs that people use. They use a histogram or a scatter plot. The histogram is a bar graph depicting distribution. I believe on the right hand side of your, well, I'm looking at the picture on your screen is an example of a histogram. It's a bar graph, okay, and it's depicting in that frequency. Scatter plots are a graph cluster of two variables with a slope that's either positive or negative. And the next slide shows you an example of that. Okay, so think of, I know this is going to sound silly, but the easiest way for me to remember this, histogram is bar graph, scatter plots are the dots. Very sophisticated way of remembering that. But in terms of scatter plots, if there's a question on your test about it, it is going to ask you if there was a positive or a negative or no slope at all. And again, I'm going to go over that in the next slide. So there are two ways which the statistics are collected and described. So we have descriptive statistics, so numerical data used to measure and describe the characteristics of a group. And then there is inferential statistics, where you are inferring information from the data. So descriptive, they're going to give you the data as is. Inferential, they're going to make an inference, a guess, based on what they're seeing, and it's probably true of most of the population. Okay, so as promised, this slide is going to tell us more about that scatter plot. So when you're analyzing the scatter plot, or really any statistic, you're looking for a correlation coefficient. You're measuring how strong a relationship between two variables is, ranging from -1 to 1 to represent a correlation. So age and income have a correlation coefficient of 0.7, meaning the older you are, the more money you're likely getting in income, right? The older you are, the more likely you have a higher income. Conversely, the weight of your car and your gas mileage have a correlation coefficient of -0.6, meaning the higher weight of your car, the less efficient the gas mileage is, right? So the graph that may have a positive skew is going to move a right skew distribution due to a long tail on the positive direction on a number line. It essentially means that the bulk of information on the graph is skewed to the right, which is a negative skew. That would be represented by a skew in the data to the left. Okay, so positive, the skew is to the right. Negative, the skew is to the left. So if you look at your picture on the bottom here, let me make sure you all can see it. Okay, so we have the left skewed negative skewness, looks like this. Right skew, positive, looks like this. Okay, so I guess one way to remember it is that the left skew and negative skew, you have more space on the left side, and a positive skew, you have more space on the right. I hope that makes sense to you. Okay, and then the bimodal is where the frequency distribution in the data set contains two peaks. So unlike a bell curve, which has one, a bimodal contains two. So the graph would look like two hills. So think of like a roller coaster, one hill and then another hill. That's bimodal. Sorry, guys. Okay, I am running out of time. So here is the picture of a positive correlation, a